Hey guys, we're going to start the chapter 5, which starts on page 285. This is the last chapter we have for semester 1 and in unit 2 and everything like that. So the first part of chapter 5 starts with mid-segments. Mid-segment of a triangle is a segment connecting the midpoints of two sides of the triangle, same triangle. If a segment joins the midpoints, remember those middle points of a line, of two sides of a triangle, then the segment is parallel to the third side and is half as long. So this sounds a little confusing. Let's try and think about what this means. So basically, if in my picture here, if D, this point here, is the midpoint of CA, and E is the midpoint of CB, so those are congruent, these sides and these sides, then DE and AB are going to be parallel. So parallel, like that. And DE is half as long as AB. So if DE is, say, 6, then AB would be 3. So that's basically what the midpoint theorem says. And what we're going to do next is going through why this works. Not an actual proof, just why this would work. Okay, so our example here says, given a triangle with vertices A being 4, 6, B being 6, 0, and C being at the origin, where D and E are the midpoints of CA, so D is the midpoint of CA and E midpoint of CB respectively, show how this would work. So I didn't draw it, but we're just going to use straight numbers for this. So first step is to do the midpoint. Remember what the midpoint formula is. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. So you take the 2 points that you're looking for, add them, and divide by 2. So to get the midpoint of CA, we do 0 and 4, and 0 and 6. 0 plus 4 over 2, 0 plus 6 over 2, 4 over 2, 6 over 2. D would be 2 over 3. Similarly, to do the midpoint for CB, to find E to get the midpoint of CB, we do 0 and 6 over 2, 0 and 0 over 2. So it's 6 over 2, and it's just 0, so E would be at 3, 0. So there we know our midpoints. Now with these midpoints, to make sure that they're parallel, we should check the slopes of them. So if they're parallel, the slopes would be the same. So step 2 is showing that the mid-segment DE is parallel to AB. So the slope formula, we do 0 minus 3 and 3 minus 2. That's for DE. 0 minus 3 and 3 minus 2, that's DE. And then for AB, we're doing 0 minus 6 and 6 minus 4. So this turns out to negative 3 over 1, negative 6 over 2, and turns out to negative 3 equals negative 3. So here we have our slopes being equal to. Now the next part is that DE is going to be 1/2 of AB. So for this one, we're going to have to use this good old distance formula for this. So we're going to use the distance formula to show that DE is 1/2 of AB. Remember what the distance formula is. It's the square root of x1 minus x2 squared plus y1 minus y2 squared. Alright, so let me just reveal this all. So we're doing DE, these 2 points, so it's 3 minus 2, the x's, squared, plus 0 minus 3 squared. 3 minus 2 is 1, 1 squared is 1. 0 minus 3 is negative 3 squared is 9, 1 plus 9 is radical 10. Now for AB, we're doing 6 minus 4 squared plus 0 minus 6 squared. 6 minus 4 is 2. 2 squared is 4. 0 minus 6 is negative 6. Negative 6 squared is positive 36. So we're having a 4 plus 36. That turns into radical 40. Now we can reduce this a little bit more. Remember, when we're reducing radicals, we can separate them into numbers that multiply together to equal each other. So I can do radical 4 times radical 10, and then 2 times radical 10. Now this is our final answer here, and this is our final answer here. So now we have just shown that DE is 1/2 of AB. In order to get from here, you divide by 2 to get to there. So we have just shown that this will always go, this will work, and this sense. Alright, now let's go into some questions where we're going to do given a triangle, and we're asked to figure out what the parallel segments are. Okay, so in our example here, we have our given triangle XYZ, and we're told that A is the midpoint of XY, B is the midpoint of YZ, and C is the midpoint of ZX. And they're asking for what are the 3 pairs of the parallel segments. So again, in most things, it's the best way to do this is to draw it out, like so. When drawn out, we have triangle XYZ, and we're told that A is the midpoint, so A cuts into these 2 parts here. YZ with B as the midpoint, so we have these 2 congruent parts over here, and XZ where C is the midpoint, so we have these 2 congruent parts over here. And we need to show which ones are parallel for here. So let's take our first segment. Let's take our first segment of AC. AC is a segment here. We're connecting the midpoints of these 2 sides. So when we're connecting the midpoints of these 2 sides, the third side would be parallel. So AC is going to be parallel to YZ. Then if we do AB, these mid-segment point here. Remember, AB is a mid-segment point. AB would be parallel to the third side, the side that's not being touched, which is XZ. And then BC, this mid-segment point here, is going to be parallel to the other third side, which is XY. So when we're identifying these parallel points, A is the midpoint of XY, so you just gotta kind of look at the picture and kind of turn your head a little bit and move around to see where the mid-segment is and where the sides that are going to be parallel for all of these different things. So written out, AC is parallel to YZ, AB is parallel to XZ, and BC is parallel to XY. So that's all that you would need for this answer here. Alright, let's go into 2 more problems. Next problem we're going to do is where we're given something similar to this, but we're going to have one more step where we're giving lengths of these things, and then we have to find lengths of other parts. So let's try an example with that. Okay, so our example here is in the figure below. AD is equal to 6. DE, this part here, is equal to 7.5. What are the lengths of DC, AC, EF, and AB here? Okay, so the first one we have is DC. Well, we could see that this AD and DC are congruent, and D is the midpoint, so we know that DC would just be 6. How about for AC? AC is this whole thing. Well, if AD is 6, and DC is also 6, then it's just 6 plus 6, which is just 12. Now this one, a little bit trickier. We have EF, this one here. How are we going to figure out this one? Well, I do remember from this here is a mid-segment point because it's cutting this into midpoints. And I know that this line will be half as long as the line that's parallel to. So if this is the midsegment here, then it's parallel to the other third leg of the triangle. Then it's also going to be half of this whole length here. So this whole length here we just figured out up here before, which is 12, and we divide it by 2, which gives us 6. And then our next one is similar. We have AB, but AB is going to be parallel to the midsegment, which is DE. And we're given DE. So this one would just be 7.5 times, that's a times sign, 2, which gives us 15. So this stuff, fairly straightforward. Just need to recognize which parts are the midsegments and which parts are parallel to each other, using the numbers and making sure you're doing the right order. Alright, we are going to do one more, which is a word problem, and then that'll be it for this lesson. Okay, example short word problem says CD is a bridge being built over a lake, as shown in the figure below. I didn't draw the lake here, but you get the idea. What is the length of the bridge? So the bridge is this point here. And in the picture, we're told that this is congruent to this, and that this is equal to 963 feet, and this is equal to 963 feet. These two are equal, so this is the midpoint, this is the midpoint. And here, this length here, the side that's parallel to CD, is 2,640. So what we need to do, when we're given the length here is 2,640, and we divide it by 2, because remember this length here is double the length of the midsegment. So 2,640 is just 1,320, sorry, 1,320 feet. Remember to make sure we have the unit at the end. Okay, so that's going to be it for today. In class, it's only going to be 40 minutes because of the science fair. So we're just going to probably only have time to do individual work for today.